What's up, what's up, what's up, what's up? Welcome back. Today we are working on recreating zlib in Zig. For no real good reason other than it's kind of fun to try stuff as a way to learn it, right? So, lossless compression is like a core component of a lot of software. Zlib is kind of like the guy backing a lot of that, like essentially the same algorithm that's used in like zips and shit. And so we want to see how does that work and see if we can implement it ourselves. So the goal is to take something that is like compressed with zlib and decompress it ourselves, and compress something ourselves that can be decompressed with zlib. And what we're at so far. Okay, so like the backbone of this like zlib compression algorithm, there is kind of like this like tree structure, and the idea is you can kind of encode a path to a node in this tree by packing left and rights into like a bunch of bits, right? So you can say going left is a 0, going right is a 1. And so down here you go like this, like this, like this. And if you were to like encode this path to take 3 rights as like a bunch of bits, that would be the number 111, which is binary, like decimal 7, right? And so the idea is, if you take some characters and you say like I have like the letter A, B, 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 C, D. C and D occur the least frequently. A occurs the most frequently. So what you can do is you can put A up here, B down here, and C and D down here. And what ends up happening is like A is encoded in a single bit 0, B is encoded in a single bit 10 or 2 bits, sorry, and C and D take 3. 110 and D is 111. So what we have is we have this like the ability to generate this tree. There's this like in the storage format of this tree that basically says like for the letter, if you have an alphabet A, B, C, D, if you store this as A takes 1 bit, B takes 2 bits, C takes 3 bits, and D takes 3 bits, apparently like that's enough to reconstruct one of the valid versions of this tree. And if you always follow the same rules, then you will always end up with the same tree. So zip files will kind of like pack this encoding into their like compressed stream, and then you have to like unpack this yourself. So we have the ability to do this. We have the ability to parse a zlib header to the point where we're getting to a block of data that's compressed this way, and we want to see basically if we can actually decode something like this. Glossed over some details there, but they're not important for today. So plan of action is there is 2 types of compression blocks that use this like Huffman encoding. One is they have like kind of like a pre-shared table. So they say like, hey, like values between 0 and 143 have 8 bits, 144 to 255 have 9 bits, and then there's like some like extra stuff that takes like 7 and 8. So they're saying, here is a table, let's load that. And then there's also a different one, a dynamic version that says, hey, this predetermined thing sucks. I want to use my own version of it. And so like maybe based off of the character frequencies in the text I'm compressing, I can do better than like what you have by your default. So I think what we want to do is we want to try loading the static one first that has like the built-in table, because that'll be less parsing, less work. And then once we get that working, then we can move on. So I think let's try to load this Huffman table and make sure that like we get what we expect to get. Then we can try to like handcraft a Huffman. We can like handcraft a deflate packet that will trigger this, and so then we can see, okay, if we handcraft this, can we decompress it with zlib, and can we decompress it ourselves? That's kind of plan of action. Plan of action. I think that's good for now. As far as I can see, this is not Lisp. Why is it not in Lisp? Is it obvious that I love Lisp? I think, I know you're making a joke, but, I'm of the opinion that programming languages don't really matter that much, right? So I'm looking at Zig right now because I feel like it's interesting to me at this point in time, but like really, in reality, who fucking cares is kind of like my more overall take on it, right? That being said, I haven't really tried the lists yet, and I should probably do it at some point, but not what I'm interested in right now. Are you going to implement the backdoor in Zig as well? Good meme, good meme. Yeah. It's pretty funny that I happened to start this project on like the day that the XZ backdoor news hit, and I just like it just happened to line up that way. I didn't really think about it. It wasn't like me trying to like cash in on the hype or on the like on the news or anything. It just happened that way. Okay. Let's look at. Okay, so the Huffman thing. They say, hey, here are bit lengths for different numbers. So if you want to print the number 0, that's going to take this code. Yes. Okay. So what we have right now is we have the ability to reconstruct based off of only bit lengths, but that's not really what this says it's doing. So when we looked up a canonical Huffman coding, it said that all you do is you take your alphabet and you store the number of bits for each symbol. And the first symbol should end up being all zeros, was my understanding. Ah, yes, okay, so that is what's happening here. So you start with bits 256, or characters 256 through 279. Those end up with the beginning of the table. Then, I see. Okay. So I guess that means that we're gonna have to take. I think the API to our like init from bit lengths is we just pass in like an array of bit lengths, and the assumption is that the length of the array is how many characters that we are like allowed to encode. So I guess here we're just going to do something like, let's make like a array list of U64s. So this is going to be the frequencies, the bit lengths for each character. So the index into this thing is going to say which character am I, and the number is going to be how many bits does this take. Then we initialize this guy with some allocator, and then we don't forget to de-initialize this at the end. So defer bit lengths de-init, or else we will have a free out memory that we've got to free, and that's a big no-no. Even though this is main, and who fucking gives a shit, the allocator will yell at us, Valgrind will yell at us, I'll yell at us, so we might as well just do it. Bit lengths, and we're gonna have to like iterate over each number. So for 0 to the maximum here is 287. So 288 is one past that. We say bit lengths append, and we have to try this because allocations can fail in this language, which is sick. Love it. And we're not appending a string, we're just appending a frequency count. So we actually kind of want to do this in chunks, I guess. So 0 to 145, we append we append 8 bits. Expected loop payload? Really? I can't just not put it? Okay, fine. For, I guess really what makes more sense is we do bit lengths resize to 287. 288, sorry, I think. 288 elements, max element 287. And then we can just do memsets. So we can do memset. Does memset not take a length? Stood. I guess we can slice this thing up. So you say bit lengths dot items from 0 to 144. We memset this to 0. Or sorry, 8. Is that right? Memset. He takes in the destination and the elements. That's the other way. Bit lengths here, 8. Okay. And we go 144 to 256 is going to be 9. And 256 to 279. 279 is going to be 7. And, oops, 280. And 280 to 288 is going to be 8 bits. Okay, so then we can try to create this Huffman table that's going to store elements of U16s, I guess, in it from bit lengths, and we pass in these bit lengths that we just shoved in there. Bit lengths items. Okay, so then in our like previous thing here, we were printing out the table on the codebook to see if that we were getting something sane. And so I guess we can still do that and just see if the codebook looks kind of like what they say it should be. He doesn't like this because I didn't write try here. Okay. So, segmentation fault. That's kind of fun. That's kind of fun. Where does that come from? Init from bit lengths. Add empty branch to node list. We're seg faulting there. That's interesting. Init from bit lengths. Okay, so that I guess we can GDB this and just kind of see what's happening. So let's look at, I guess, seg fault is on something. Nodes? How do I even tell like what is going on here? We're seg faulting at line 144, which is here. So it must be on the assignment to branch, because otherwise we would get into this function. Okay, so what is this code trying to do? Oops, p branch. Oh, I think it actually told us where it was seg faulting, did it not? I seem to remember seeing the address. At address. Segmentation fault at address this. Which is this. Yes, okay. So this code is, he's basically constructing codes based off of the bit lengths following the algorithm here. So he says for each code, essentially it's smallest things go to value 0. And as you go up in bit lengths, you take right branches. So, right, if you have like, you have something at like bit like here, he's going to be on the 0 path. Then you take 1 to go right, and then things are sorted by, you wouldn't get like CD here, or sorry, you wouldn't get like DC here because those are alphabetically in the wrong order. So you'd put CD here. Is essentially what it's supposed to be doing. That's what it's supposed to be doing. And so this assignment is trying to say, he knows that the codes for these guys, so he knows that like A is 0, and C is 1, 0, and D is 1, 1, and he's trying to reconstruct this tree out of it. So he's saying like, okay, as I walk through this like D code, I have to take like a right branch and a right branch, and he's like populating the tree with like nodes that have branches in them. And here he's trying to say, hey, the next level didn't exist yet. Let me like put a node into the tree, and that's failing because on assignment to the previous node, which is kind of interesting. So why is that? We can look at info locals maybe. Okay, so what code are we trying to look at? That's code iterator. Code is 8. Code is 8. That doesn't sound right at all. That's such a small number. Oh, but the bit length is going to be long? Hold on. Let's list p code. P lm bit length. Fuck. I need the code as reference. So we are here, and I want to see lm length, bit length. How many bits is this supposed to be? This is supposed to be 7 bits, and the code is 8. So that's a lot of lefts, and then a couple rights. No, a lot of lefts, a single right. then a bunch of lefts. Okay. So here we should have branch. This is invalid memory. Okay, so that's reasonable. Node.branch. So what is node here? Cannot access memory. So the node itself is completely invalid memory, which is kind of fucked. So what are these nodes? Storage for these guys is like we have like an array of nodes like this. And we store like the index to which one we're looking at. And so here our index is supposed to be something 19. So we're 19 elements into this array, where our array is, does this exist? Nodes. Well, we have an array of length 21 with items at this address. Is this valid? P nodes items. Yeah, that seems okay. Block pointer. Oh, let's try dereferencing this. Is this valid? Yeah, that's great. So nodes items pointer plus 20 plus what was the index? 19? That is the address that we're trying to dereference, and that's that it's segfaulting on. So if I dereference this guy, there's no problem. So that's kind of interesting. Why is that okay? But if I look at p branch, which has the same fucking address, what's the difference? Nodes items pointer is a pointer to node U16s. Branch is a pointer to the same thing, but as a union element or something. So here I said branch is equal to node.branch, and then I assign it. And is that just not legal? Yeah, that might not be legal. So I might have to do, let's just see what happens if I do node.bigB branch here. Which I didn't think I had to do here, but it could just be that I don't fucking understand the language yet. Okay, let's try that and see what happens. Ah, access to union field branch while leaf is active. Ah, so there's just like a bug somewhere in here. Node index is node.branch.write. Okay. So what's interesting is I don't think this was happening earlier. So that explains the seg fault, at least. But like before, when this looked like a bunch of, you know, if we had like some U64s, 0, 1, or like 3, 3, 1, 2 or something, I don't think this was like crashing. It was just working fine. Yeah, that worked okay. So it seems like as we increase the number of items, we're starting to have bigger problems. Let's just get a little crazy. I was gonna say let's like reduce the size of this like bit length input for a second, but I decided I actually changed my mind. I don't want to do that. GDB zig build and run. And I guess it would make sense for us to maybe log what we're trying to do at each stage here. So here we go like std debug print working on index something. Just to see if we're like getting through lots of iterations of the loop or we're on our first one. So we're almost like immediately crashing. Okay. And maybe what makes sense is, can we like break on panic in Zig? where does this panic come from? Because I know in Rust you can just say like break on Rust panic, but I don't know if you can in Zig. Zig GDB break on panic. That's pretty funny. I look up specifically Zig and it's like Rust. Super cool, super cool. Okay, let's see. How does this work? How does this work? I guess we'll just run it. Run. And we get a panic. Oh, perfect. We actually get a backtrace exactly where I want. Perfect, 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 perfect. Oh, sorry. Gross. Sick. Hate being sick, man. Okay. So can we maybe print the tree in its current state? What have we built so far? That'll give us a clue. So we have self tree nodes. There's no self yet, nodes. Okay, and we have, do we have the root yet? Root is index 0. Okay, so p nodes dot items dot pointer, and he's saying that there's 9 of these things, so we should be able to do like dereference 9 of these guys. Okay. So our first thing is a branch where it tries to go left to index 1. So you see like tag equals branch, then we go left. Okay, so at index 1, we have another branch. Okay. Oh, I see. This is based off of... there's a lot of stuff in here already, because we're trying to walk left, right, left, right, left, right to get to like this like 8 deep thing, right? We have... you know, some code 110001. Even though it's like one of the first elements we're putting in, we've already kind of constructed a pretty thick tree because we have to go right, right, left, 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 right, kind of thing. Okay. Okay. So that makes sense. So it could be either our codes aren't lining up right, or we're not walking the code correctly. Yeah. So let's working on index this code will write out in binary what it is. Or I guess we could just print it now, actually. That's probably better. So we can just say key elem length, maybe is what we want. And so here we have 7 bits, and the elem is 257. Right, okay, and the code is 1. So what we should see in our code iterator that we just ran is we should see this is 0000001 with 7 bits long. So 1, 2, 3, 4, 5, 6, 7. So we should see a bunch of left, then us. So maybe here what we can do is we can print out which path we took. Walking, and we print the walked-er. Okay. And here we should also print the code. Okay. All right. He doesn't like that for some reason. Expected. Oh, I forgot to put a curly brace here. He needs an anonymous structure to walk. Okay. Okay, so we did see false, 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 true. But at that point in the tree, it thinks that there's a leaf node, which is unexpected. So can we look at nodes. P, what is it called? Oh, backtrace. We need to go to the right place in the stack, which is frame 8. P nodes. P nodes dot items pointer. And we want to print all 9 elements. So root left is 1, which goes to index 2, which is left 2, which is here 3, yep, 4, 5. No, 5. Yes. Okay, sorry. So this is 1, 2, 3, 4, 5, which is 6, 7. So everything is left 7, blah, blah, blah. And so we were supposed to be walking left, 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 left. 1, 2, 3, 4, 5, 6. So on the 6th one, he went right. So it's 1. So on branch 6 here, he has a right value of u size max and a left value of 7. Okay, so what the fuck is the problem here? Also kind of weird. We are crashing on line 140. Ah, okay. So, no. What the fuck? Line 140? That's here. Which is assignment of node index. But we just looked at node.branch here. So he's saying like, hey, you're using the wrong type of the union. But how is it changing between these two statements? This looks like just totally invalid memory. That's interesting. So that's like super invalid. So why is that happening? Ah, okay, wait, there's a clue. Let's go. So our node index is 6. So can we say pointer plus 6? Okay, whoa. What's going on here? So if we print out this guy directly, his value in the array, it looks fine. Oh, fuck me. Oh, okay, hold on. This add empty branch to node list is reallocating the fucking array. Yeah. God damn it. I've been in Rustland too long, and so I'm just automatically I'm just like assuming that these things are taken care of for me, and they're not. Obviously. Okay. So the problem is here we have an array. Right? An array of nodes, like we were talking about earlier. Node, right? Then we take a pointer to this guy. So this is at address like 1, 2, 3, 4. And, you know, we want like this pointer to him. So this is a pointer to like 0x1240. It doesn't fucking matter, right? Like, well, who cares? If that's the wrong number, but we'll run with it. Then we say like, hey, I need to like add some nodes to this guy. So I need to like push in a couple more ends here for the like branch options with this like add empty branch to node list. And what happens is he goes like, oh fuck, I don't have enough memory. Oh, what the fuck just happened? So he's like, I'm gonna make a new array, and it's gonna be twice as big, and I'm gonna fit all sorts of things in here. And this guy goes, bye. And so this is at like some new memory address, 0xabcd, and the pointer we should update this pointer to point to 0xab40 or whatever, right? Like it's a new address, and we're just not doing that because I'm a fucking idiot. So this is wrong. And here, I have to say, what? What? Var new idx equal to this. And now here I have to say node is equal to nodes items node idx. Then we can assign this to new idx like this. Gross. So easy to forget stuff like that. So easy. Undeclared identifier new IDX. Here, oops. Cannot assign to constant, so we need to make this var instead of node. And let's see if that fixes the crash. Better, not great, but better. Index out of bounds, so index is usize max, that looks like. Oh, because this is supposed to say left here. Oops. Oopsies. There we go. Okay. Sick. So crash fixed. Nice. And now let's try to print out the codes that we generate here. So we can say, instead of just printing the codebook, what we should do is we should say for 0 to codebook to len, we will print the index and its code as Boolean. And we can just say I and codebook to I items. I. Yeah. And here we'll even throw a little huff fixed code book. Yeah, like this. Cool. He doesn't like that because this can be items.len, not len. And what does he not like here? Cannot format optional without format specifier. Where is this coming from? I mean, it has to be in one of the, like, is it this one? Zig build. Is it this one? Yeah, it was that one. So what the fuck is wrong with this print statement? What? Cannot format an optional without a format specifier. Which one of these is an optional? I is a fucking usize. Codebook to, oh, the codebook is a, I'm an idiot. Codebook is returning codes, and the optional codes that tell me like the number of bits and shit. So I have to say if codebook to items I var code is equal to this or else continue. Then we can print the code. Yeah, there we go. Whoopsies. Okay. So let's see if this at least somewhat matches what we expect from the RFC here. And then also let's kind of make sure that these are all padded the same, or else I'm gonna get like fucking lost. This is like really fucking confusing. So can we say, what is it, like leading zeros, like 8 zeros and B or something? How do we do this? Fuck. I guess we have to go to the format specifier thing in the language spec, like the standard library. Here we go. Argument specifier fill. So fill is a single character which is used to pad the formatted text. And then width. So alignment is one of these guys. So we need to go left, center, or right aligned. So probably we want right aligned. So we want to fill with zeros. Or maybe on the left. And we want to make sure that it's like 8 characters long or something. Did I get it wrong? Where's the B supposed to go? The B goes specifier. Oh, so B goes on the left of the colon. My bad, my bad, my bad. Right here. There we go. Okay. And it looks like we actually want 9 here, not 8. And it looks like we're padding on the wrong side here. All the zeros are on the right, and we want them to be on the left, so switch that little bracket around. Okay. So let's see if this lines up. So they're saying 256 to 279 is 0000 through 0010111. And what the fuck is going on here? Are 256 and 257 not supposed to be adjacent code words? Oh, fuck me. Okay, hold on. Okay, how do I explain this? Okay, so in this, they are saying read this code left to right. I'm pretty sure. We'll find out in a second, but I think that's what they're saying. So they're saying that, you know, if you have 1 0 0 0 0, that results in a right branch, then left, 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 left. Now, what's fucking confusing about this is the bit packing, like the representation of this in the in the spec of how these are packed into a file is that you go. So if you were to read a file, kind of like starting from byte 0, where you have like A, B, C, D in your file, right? You start here at offset 0, A, B, C, D, and you kind of move like left to right. But if you then were to like pack lots of bits in here, you have to determine like if my A is represented by, I'm going to pick a binary number that's wrong, but we're just going to throw something in there, like 01011. You could either start from reading from the left or from the most significant bit or the least significant bit. And the way they define it is that you should start reading from the least significant bit. So even though here they're kind of saying, hey, I'm tree walking left to right, like you actually have to swap this around in order to actually write it to the file, which is very confusing. At least that's my current understanding. We could be wrong, right? We'll find out if we're wrong, but I don't think I am. And what's even more fucking confusing is that the number of bits that are used here is variable, right? So what we actually have to do is we have to invert the bits, preserving the leading zeros. Oh, that's such a pain in my ass. Okay, so we have to do something like, I think there's like a bit swap thing in Zig language reference. Bit swap, maybe it's in the standard library, bit reverse, maybe that's what I'm looking for. Accept any integer, blah, 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 reverses the bit pattern of an integer value. So they just, for example, blah, 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 maybe that's not what I want. Oh, what a fucking pain in the ass, man. Bit reverse. That is what, except, so reverses the bit pattern. So we have 1011, and we just have 1011 reading from right to left. So this is kind of what I want, except that we need to preserve the bit width. So we need to do something like, oh god, oh, this is gonna suck. Okay, so we have num bits stored in here. So if we have like 0b 000101, or let's say 001, we have, yeah, just the number 1. And we have num bits 3. We want to turn that into 0b, bunch of leading zeros, and then 1 0 0. So I think that we do bit reverse on the value, and that will make it so that we get like 0b 1 0 0 0 0 0, right? And then we just have to shift it right until we're back at the right number. And I think that's right. So we do like code val, bit reverse it, shift it right by bit size of code val minus code num bits. I think. Maybe. And then in here, we'll just print out the old val. No, we won't. I don't. That's what I do. I think that's right, but we'll see. He doesn't like something here. Unable to evaluate comp time expression. So this probably bit size of probably takes in a type. Yeah, so we need to do type of code val like this. Found type U8, found U64, or expected type U6, found U64. So we have to int cast this whole thing to make sure that we're not shifting by some absurdly large number, because the type system doesn't like guarantee that. Okay, that looks right. It looks, we can tell it's right because we're seeing 0, 1, 1, 0, 1, 1, 1, 0, 0. Like, these are incrementing in number correctly. And so we are seeing that this matches this guy. So just to clarify what we've done is we took in their code, right? They're saying, here are our numbers. We turned that into a tree, and then we serialize the tree back into codes. And so what we want to make sure here is that the codes that we get back out are the codes that we expected to get in. And I think that is what's happening. So 256 to 279 should just be incrementing a number. 256 to 279, great. Then there's a big gap before 280. So then for 8 we should see 0 to 143 be like the next set. 0 to 143. Here. Boom. And then we should see this should continue on with 0, 1, 1, 0, 0, 0, 0, 0 at 280. Which we do see. 0, 1, 1, 0, 0, 0, 0, 0. Perfect. That's sick. And then we should see 144, 255 to take on the rest. 144, 1, 1, 255. Yeah. Yeah, great. Perfect. That looks great. And then, yeah, no, that's sick. That's sick. Okay. So I think it's right. I think. Maybe. And so now we can try to like use this in order to build up a compressed blob that is using this tree. Okay. So how do we do that? How do we do that? I guess I should write the time down here, or else later I'm going to regret it. Oopsies. Oh no. Oh no. Stream to do 2024 04 10. Set sign column equals no. Set line break. There we go. Whew. That was sketchy. Okay, so we all have this function where we generate zlib no compression. So this is just generating zlib blob. For now, we'll just copy paste this and we'll say generate zlib static Huffman block. And I guess in this function, maybe we have some like function that's like get Huffman, get fixed Huffman table. That seems reasonable. And he's going to return a Huffman table, which we probably need to import. So import huffman.zig huffman table. Sure. Maybe we'll just import the whole module. So here we'll import huffman.huffman table. Nice. Okay, and so this is essentially just going to be this code that we wrote here. Like this. Boom. Easy. We need to take in an allocator here. Okay. Which needs to be imported. Like that. Boom. And now, when we generate a static Huffman, we can start by getting our Huffman table. So Huffman table is equal to get fixed Huffman table. I guess this shouldn't really live. Oh yeah, I can live here. Fuck it. I was gonna say, like, should it live in the Huffman block or in the zlib block? And I guess I was going to say we can move it into the Huffman block, but I think Huffman coding doesn't really care about this particular table. This particular table is more of like a zlib concept or a deflate concept, so we'll leave it here. We'll leave it here. So, boom, get the table. Then we need to get the codebook out of it. So, Huffman table generate codebook. I guess technically we could skip the part where we make the table. But whatever, it's fine. This is kind of like we could just go straight to the codebook. Theoretically, but I'm not going to. Okay, so then we have to generate our zlib header. So this should be, I think this is the same. So this is saying use deflate. This is something about like window size that we aren't using yet. And then some flags for, like this is like compression level, a checksum, and something that we just don't want to support right now. Okay. So that's great. We write that in, we write our header in. And then here is where we started doing like block specific things. So before we wrote in, hey, we are a, what were we trying to do here? A final block with that's non-compressed. So now we want to say, hey, we're compressed with fixed Huffman codes. So we want to say 0B011 here. Change from 00 to 01. And then we need to look at actually what the format of this thing is. So I think the algorithm is here. If compressed with dynamic Huffman codes, read representation of the code trees. But then we loop until the end of block code is recognized. So while the value is less than 256, we copy literal byte output to the stream. And we're going to ignore these like distance codes for now. So we can generate something that I think it's just, we just put things into the bit, we like pack some bits in there. Great. Okay. So here we actually need to be able to like serialize bitwise. We need to pack some bits in here. Pack a bit, you know? So let's think about this. Here we are writing to some writer, some backing file stream or buffer or like array, whatever, it doesn't matter. And here we need to create like a Huffman writer maybe. That sounds right. Var Huffman writer is equal to, oh, okay, I think it's okay. So var Huffman writer is equal to Huffman writer, and he takes in a writer. What else did he take in? And a codebook. Uh-huh. And what is in this guy? He's got a bit writer directly inside him. So we could just directly use his bit writer as a Huffman writer write bits. We want to write 3 bits here. That is the header. And then I think that we can just call Huffman writer, and then we can just start writing shit. I think. That seems possible. What does this guy do? So he like iterates over the data, and for each chunk of data, he looks up the code and then writes it in as write bits, and then we just have to finish this thing. And probably these can fail. I didn't actually look. This can fail. This can fail. Yep. Yeah. And then it might just be done. That seems like legitimately could be it. And I guess instead of hello world, we'll write the data. And I guess let's just take a little peek skis at that and see if it generates something sane. So what do we want to do here? Instead of this thing that we were doing before where we try generating Huffman tables, blah, 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 we'll just delete this scratch code from yesterday. And instead we'll say, maybe we'll go into our demo custom decompressor. Nah, we'll just do it up here, fuck it. What do we want to do? We want to say generate zlib static Huffman. What is this? Yeah, z dot generate static Huffman. We pass in our allocator as well as a writer. So I guess we're gonna have some sort of like buffer that we're writing to. Yep. So we pass in a writer to this guy. So we need to say var stream is equal to stood io fixed buffer stream, grab the buffer, and then we grab the writer of that stream.writer. Great. And then what's the last piece here? A string that we want to write out. Hello world. And then this is going to tell us how much it wrote. So buff size equal this, or compressed size. And maybe we'll call this compressed just for consistency. This guy needs to be tried, and then we can I guess try to decode this thing with zlib. So we can take the input data of compressed from 0 to compressed size and try to output into decompressed. And maybe we try this. No, we don't. Because this is guaranteed to fail with how we've got this set up right now. I'm not really worried about it. And then in here, maybe we can just try to print out. We'll just see what happens. We'll see what happens. Zig, build, and run. Okay. Invalid type given to fixed buffer stream. Does he expect this to be like ampersand? Okay. Expected type found Huffman table. Oh, because Huffman table, he has a type associated with it. So we'll just say U16 for now. Codebook. This guy is probably ampersand. No. He's an error union. We have to try to make him. So we generate him. We have to type try here to unwrap the error. Great. And then here, is this not... Maybe it's codebook items. Yeah, that's probably it. Close. Address of operator to coerce. So here, this guy needs a little slappy wappy. And error is discarded. So can we just kind of... I think it's catch, error, discard. Okay, reached unreachable code. at an assertion failure called from here, trait is unsigned it in bitwriter. Great. Where, like, I wish I could see where this is coming from. But I guess we can just look. It's at line 38. So it's here. So someone calling write bits is mad that u is not an unsigned int. So he's looking at the type of the value. He's like, it's not an unsigned int. So maybe this has to be like as u8 or something. Or else he gets mad. Yeah, that looks like it. Okay. So let's get rid of some of these annoying debug prints. This one and this one, I think, are the annoying ones. Okay. Okay, we're getting error input data, blah, blah, blah. But it looks... how do we want to handle this now? What were we doing yesterday? We were debugging by looking at what happened to the decompressed stuff. So it errors out because there's like a compression, like, I want to say CRC is the wrong word. There's like some checksum at the end. And our generated blocks just aren't making those right now. But we could see if, even though it fails, if we get something like somewhat sane here. So here we could like say stood. Maybe we'll just break one here. That's probably easier. Okay. So info locals, we have a Z stream. And he made it through 11 bytes of output. And can we maybe info args? Our output buff does have the word hello world in it, which is a very, very good sign. That's a very good sign. So that looks like we compressed something by hand there using our compressor. We generated this block using the table that we imported from the RFC. And it looks like that it generated something that was sane enough that the actual zlib decompressor has gotten the same text back out. So that's a really good sign. That's a really good sign. Yeah, no, it's sick. That's sick. So this is just working. Hell yeah. That's really cool. Super fucking cool. Okay. So now we have a block to play with that we know is sane and we know what's supposed to be in it. And so we can start trying to decompress it ourselves. Super sick. Okay. So if we get fixed Huffman codes, we should be able to, I guess, get the fixed Huffman table, who should maybe just be stored as part of this guy, because we're just gonna maybe gonna be called a lot. So we'll say fixed Huffman table is a Huffman table with type U16 as its backing storage. When we construct this guy, we have to say fixed Huffman table is equal to get fixed Huffman table with an allocator passed in, right? Is that, yep, which means that this guy needs to be initialized with an allocator. So here, when we, somewhere here, I guess we're going to switch to using our zlib decompressor. So zlib decompressor with alloc and reader, which probably means that I think that this is called through some other function here. Yeah, so this also needs the allocator. This. Okay. And then we can say decompressor. This is probably try and decompressor dot read block. Yes. And this is going to go into decompressed. Okay. And our reader here should actually be stream reader. And then we stream reset before we do it. Okay. Chillin'. Okay. Yeah, cool. Cool. So what are we doing here? We are going to read this block. Great. Everyone's happy. Probably we need to add a deinit function here because we have a Huffman table that we need to free. So pub function deinit self is self. And it's just self fixed Huffman table deinit. There we go. Holy crap, that T made it far from where we're supposed to. Okay. So now we get to this fixed Huffman table block. And I guess we just start fucking going, right? So we say var reader is going to be a Huffman reader. And he actually has to pass in his bit reader. So I think that our Huffman reader kind of assumes that the reader is going to be something that reads byte by byte. He does. And since we're starting the reading process like halfway through a bit, I guess it makes sense to upgrade this now to use like just a normal bit reader. The standard interface. I was trying to avoid it before because I didn't think we needed it, but it seems like it's probably time to upgrade now. So this is going to be stood out bit reader given some reader. Is that how this works? Bit reader. I have to write little as well, little Indian here. We don't have this current byte and byte progress anymore, but the rest we still do. Okay, so next bit now is just going to be self reader read bits, and he's going to read 1 bits. So he's going to take in a U8. Whoa, what is the type here? Read bits from the stream and returns a specified unsigned int type containing them in the least significant end. The number of bits successfully read is placed in out bits. Ah, I see. So I'm saying, hey, get me a U8, 1 bit, and tell me how many bits you read. Like this. And maybe I want to get a U1. Okay. And I think that's just it. There's something about, like, if num bits is equal to 0. I guess we'll just assert num bits is equal to 1. Because I think that if it fails to read, this should error out. And this should never return 0, I think. But we'll find out. And then probably we should just run our existing tests to make sure that everything works out. But there are errors that we have to fix, probably that we just introduced. This is in zlib 198. Get fixed Huffman table alloc. Why doesn't he like that? Expected type Huffman table blah blah blah. Found type info type of error union. Ah, it's supposed to be try. Okay. 247. Oh, we didn't finish this. We'll just comment this out for now. And array literal, this requires address of in main.zig. This. Error is ignored. Try. Value of view size ignored. 180. Oh my god. I don't care. Expected this type got this other type. So huffman.zig 393. Right. So we just changed this thing to want to be a bit reader, which means that this guy has to be passed in a bit reader, which means that whoever calls Huffman reader who calls this, needs to actually feed in bit reader is equal to std io bit reader. With little endian and buff reader like this guy takes in the bit reader now, and in our tests we have to give it the same treatment. So this is a std io bit reader with little endian and this guy. Okay. Hopefully that all just kind of works out. Zig build test. Expected 2 arguments found 1. Here we have to pass in our allocator. So we have to pass this in here. Alloc. Expected type this. Oh god fucking damn it. God damn it. So much work for something so simple. So Huffman reader, we want this to take in a bit reader. He assigns him directly. This is type of reader. This is a problem. So the bit reader. So I take in my reader has a comp time reader type, and I guess here I can just use that directly. Okay, a lot closer. And then there's a current byte field that we can just smoke. We don't have these anymore. Okay, sick. It built and our tests passed, I think. We should just double check here by introducing a bug. So we can do something here like we try to read, 2 bits instead of 1. And then return truncate red or something. Just to prove to ourselves that if we fuck up, we fuck up. And that sure is not working correctly, which is great, which means that our tests are running the code we think they're running and everybody's happy. Okay. So we now have the ability to pass in a bit reader to this guy that's already in some unknown state, which is great. And so here, now, our Huffman reader takes in our self-reader. Ooh. We kind of want to take him in by reference, eh? I think we do. Because we need to make sure that any state changes that we make from within the Huffman reader make their way out to the caller, to whoever's using them. So this guy has to be and self-reader. And we need to provide the table as well. And maximum length. So how many bytes we expect it to code. Is that not part of here? Oh, he doesn't know how many bytes. He just goes to the 256 till he sees the value 256. Interesting. So the idea of this guy... Oh, this is fine. We'll just pass in a max len of usize max. Stood math max int usize, so that we never hit it. And then we will just like exit the loop ourselves. Okay, so we say while reader next, we get some value. Who I think he actually had hard coded as a U8 there. I saw this is wrong. This needs to be some type T or output. Yeah. Yeah. So return val, which comes from leaf. Perfect. Perfecto. And I guess for now, we'll just print the val. And then we have to say if val is equal to 6, break. We are done. Sure. Okay, so there's some problems with table dot. Sure, I don't see any problems here. Cannot dereference non-pointer type of huffing table. Oh, I see. So here we have to pass in the table as a pointer here. Great. And then no function name read bits in bit reader star. So do I have to manually dereference this? No field or member function named read bits in bit reader blah blah blah. Referenced by read block in next. So 248. Okay. Expected type. Oh, okay. This seems more. I see. Expected type star star, but found single star. Whoa. Why is he expecting star star? What the fuck? Oh. I see. Maybe this is fine. Okay. Expected struct or tuple argument found U16. And that's somewhere we're format debugging, and I forgot to write some squiggly braces. As always. And we build. Okay. So we are getting invalid zlib header at our 179. Which is interesting because the stream that we, like that stream, we managed to feed. Oh, I'm an idiot. Well, I was using the. Oh, no, wait, no, that's right. We should be able to feed the compressed stream as a reader into the decompressor. And he's saying that's an invalid header, but we know, like, when we decompressed with regular zlib, he thought it was fine. So that's interesting. Interesting. So let's look at that. Invalid zlib header. So that comes from here. And we even print the header first. Okay, so what do we print? We print a header where we have... Yeah, that is just fucked. That's not a valid header. I expect this to be 8, this to be 3, this to be something else. So something's wrong here. Definitely something is wrong here. But I don't know what. I don't know what yet. So maybe let's just break here. And see if we get any clues. GDB, break on this, run. And can we just like print on the reader or something? Okay. So how do I... So the buffer pointer is pointing to this value. Our reader is pointing to this, offset 0. So if I go up a frame now, up another one, can I see... This would be P compressed. Where is this guy? This is at this address, which is the same as this address. So that seems fine. Oh, wait. Do we never generate... What happened to the code that generates the block? I'm an idiot. I just deleted some code that I didn't mean to. Here we go. Yeah, oops. Oh, it's probably I saw this unused local variable and I was like, oh, delete time. Okay, let's try that. Expected 3 arguments, right? So this is writer and data. Right, so stream writer here, boom. And then we have to try. All right, much better. Okay, so we draw a fuck ton of 37s. Holy. I guess we didn't actually... We're supposed to append a 256 to our zlib block as like a sentinel value to stop at, and we're just not doing that. So that could be related here. So here can we like... write 256 here? Does Huffman writer assume that we're writing individual bytes? Data const u8. So can we do something like comp time type t is a type? That's annoying. Pain in my ass. Maybe instead we'll say pub, when we finish, we'll just write the bits of 256. So we need to look for code book for the value 256 by hand. Oh, but this is like a generic Huffman thing, so we can't do it there. Fuck off. Fine. Like, so this write function has to take in arbitrary t's. Which is fine. Yeah, okay, that's fine. That's fine. So that's gonna stop compiling, which is fine. So we have to go zlib, zig, 170. So here we need to say, hey, we're running U16s here. And here we are going to pass in the value 256 as U16 slice. So that we have like our sentinel end value. Yep. Is there anyone else here at expected type U16 found type? Let's wait. Where 46? Where is this? What? Expected type const U16 found const U8. Pointer type child cannot cast into a pointer with child type U16. What am I missing here? Input data is const U8. The fuck? I feel mental. Pointer type child U8 cannot cast into pointer type child U16. Okay. But these are lengths. Why are these? There's no slices involved here. What a strange error. This is at line 46. Like, am I high? Like, if I do that, does it go away? Oh, it's just not a helpful error. Okay. Sure. So it's whoever's calling compress with zlib. Is for some reason trying to write U8s instead of U. Where's the U16 coming from? Can someone explain what we're doing? Like, I'm a junior web dev. Yeah. Okay. So, from web dev perspective, when you like fetch assets from a server, one of the things that you can do is you can ask the server to gzip stuff up for you, and then the browser will automatically decompress it so that you save like bandwidth, right? You can get the same data. You can like take your HTML, punch it into something smaller with gzip, send it over to server decompresses. And so what I'm trying to figure out is like, what the fuck is going on when you do that? What is gzip doing under the hood? So we're looking at taking like the deflate algorithm, which is kind of the basis for like a bunch of different compression methods, right? Like PNGs, zips, gzips, zlib. Like they're all kind of like the same, but they all kind of have like extra headers tacked on, but they're under the hood, they're kind of like whatever, it's the same shit. So we're looking at deflate through the lens of zlib, which is like this like super base Linux library that's used fucking everywhere. And we're just trying to re-implement it to see how it works. And so what we're at right now is we have kind of we've manually constructed some blocks. There are like different types of compressed blocks in there. There might be some that are uncompressed, some that are compressed with like a specific table, some that are compressed with like a dynamic table that is like optimized for this specific chunk of text. And we're working on decompressing something that we hand generated. And we're in the weeds a little bit with compiler errors. A little bit, but that's okay. We'll get there. I'm not really convinced that this build is doing what it's supposed to, so I'm just going to clear everything. I know there's a lot of caching in the Zig build system. It looks like it's consistent, so that's good. I don't want to lose faith in their caching, because that would fucking suck. But I really don't understand what the fuck is going on here. Arg's input data is a U8. Zlib compression buff, also a buffer of U8. So where is this like U16 shit that it's complaining about coming from? Like, I just don't understand. Nowhere in here did we do anything U16 related. Right, the only thing we fucking changed was our custom writer started using U16s, but that's like unrelated to any of this. What the fuck is going on? I think that the compiler's like somewhat confused about where this error is coming from. It feels confused. Because like anything that's U16 U8 related should be in the Huffman writer that we just changed. Here. We said, hey, here is a comp time parameter. Oh. Maybe it's I guess anywhere that we kind of fucked this up, we didn't pass on the right amount of parameters. That could be like a point where this error is coming from. What's in my fucking get different now? Fuck, there's so much. I can't just stash. I should have committed earlier. Okay, here's what we're going to do. We're going to roll back this U16 shit. We're going to say, hey, this guy is always going to write U8s again. Just for now, because we're struggling. Okay, so we'll go back to this version. And does everything build here? Yes. And so let's git add -u, git commit -m, smiley face, just as a checkpoint. And now we can go back to adding this stuff back in. So let's go a little slow. Here we're going to say, hey, here is a type, and you could be data of that type. So now when we call this, we have to say, hey, we're using U16s. Ah, that's what it is. So it's when we generate this guy, we have like a string with U8s, but then we're kind of saying, hey, we're expecting the data to be U16s, but maybe I can just say write this as if it's U8s, and then we'll throw a U16 in here. That might work. So this guy we could also say U8. Okay, cool. Now we're compiling again. That compiler error was fucked, man. That was fucked. Okay, so now let's try writing out this like 256 sentinel value that says, hey, if I see this, we're at the fucking end of the stream. And let's just kind of see what happens there. Sick. That compiles again, which is very good. Very good sign. Which means that probably we can probably run this again and just see what happens. Okay, so that's really good. We did decompress something. So HELLO space WORLD, hello world. I think that's right. I think that's fucking right. And it stopped at the 256. That's really fucking sick. I think it's working. I think it's working. So let's get a little, let's do what we're supposed to do and copy paste this stuff to the output. Hopefully some of these bad error messages are improved in 0.12. I know there's been some work done there recently. I know for sure that I tried 0.12 the other day because I was seeing that like error backtraces at compile time weren't working, and I was like, oh, maybe like I'll take a stab at it if because it was like pissing me off that like you just pass in the wrong type to some function and you don't know what happened anymore. But yeah, I saw at the very least that's fixed, where like if you just pass in the wrong type somewhere and you get a compile error, it backtraces the whole thing. It's very nice. So I know that there has been some work, and hopefully something like this gets fixed as well. What color scheme are you using? So this is Sonokai, I think. But it's kind of fucked because it doesn't actually look anything like they do here. Their colors are much more vibrant, and I think it's because there's like set GUI colors, set term GUI colors. Yeah. Onset term GUI colors. So onset term set term no term GUI colors. That's what it is. So I just happen to not be using the correct colors from this color scheme, and it ends up making it look kind of unique. I've got that question a lot of times. So it's probably doing something like using the closest ANSI color code value that matches, and then in Alacrity, probably there's some default color scheme that I happen to be using, and those are just like kind of mapping into like whatever it ends up as. If you ever update this value to 0.12, you have to change a lot of vars to const. Oh, sick! Compile errors on mutable variables? Does it compile error if the mutable variables are never mutated or something? Okay, so what am I supposed to do here? Instead of just printing this thing, we should just like feed it into the output. So, what were we doing before? We said self reader read all, and we copy that into the output. I guess here we say var output idx is equal 0. Yeah, that seems reasonable. And then we say for each of these guys, output idx plus equals 1, and we just write output idx is equal to val. And then probably have to return how much we wrote. So we have to return output idx. Cool. And then do we increment this after we break? Probably. No, before. Because this is the length that we're supposed to output. So the last character we don't output anything, but there goes one pass, and so we're at the length instead of the last index. Perfect. I think it says something like var x is never mutated. Man, that's so sick. That's gonna be such a pain in my ass, but I kind of like it. Okay. So here we can call this like var num red or decompressed len, and then we can try to print that out. And we can say what that we want, like I guess we just want to print the decompressed text. Decompressed text as a string with a new line. Decompressed from 0 to decompressed len. Cool. Does that work? Output IDX, he doesn't like this. He needs to be coerced into like a U size something. Expected val found U16, right? So we're gonna int cast this. Sig build, boom. And integer cast truncated bits. Oh, because we should only do that in the case. Right, so it's like if val is equal to 256, break. If val is less than 256, we do this. Yeah. Yeah, where does this output +1 go? We kind of want this everywhere. I guess we'll just do this. We'll put it here, and then at the very end, we'll just return +1 here. That kind of makes it all work out. We did get the decompressed text hello world, which is very good, but we have a bunch of memory leaks that we didn't deal with, so is it going to tell us from where? Get fixed Huffman table. Right, so probably our decompressor on dinit, he does free up who he's supposed to. Maybe generate static Huffman. This guy has defer Huffman table dinit like this. dinit, and I think the codebook also has to be freed. I think that got rid of some, but there's a couple more. So here at Huffman Zig, line 302, we have some node appends. So probably it's when we init from bit lengths somewhere, we are not freeing them out. Return try this. Ooh, was there like do I need to error defer free this? I do, but I don't think this is the bug. And holy shit, like, I know that I'm gonna struggle with this for a long time. And I like get the reasons for why to use defer over like destructors, but I don't know if I'm ever gonna get there, man. Especially on error paths, there's a good chance that I just fuck this up all over the place for like the rest of my life. Who calls get fix Huffman table? That guy's fine. Zlib decompressor. Maybe I'm not deniting everywhere I use zlib decompressor. One here, yeah. Defer decompressor dinit. Jeez. All right, we're chilling. There we go. Run random exch file safe so the compiler is happy with you. Let me go back to my cave with my yeah. I agree. There's something that's really ass backwards about the compiler. So the argument for like things like variables having to be mutable only if they're used mutably. The argument for that being an error is that like if you were like you should know, and if like you might have made a mistake. If you made something mutable, you must have done it on purpose. So if you made something mutable and you never mutated it, what the fuck? You must have forgotten to write some code. There's a bug. And so the concept of like the language being like, yo bitch, you forgot? Bug? I kind of get that. I prefer it as a warning, but I get the rationale for making that error. But then like sticking on top of that, a tool that undoes that for you is like so ass backwards, right? Being like, I will add this thing that I will consider an error, and then I will add a tool to hide that error from me by writing extra code is like, what are we doing, man? What are we doing? Which is why I think like using it as a warning makes more sense, right? Like that way you can choose, you'd be like, I don't give a shit. Especially something I do all the time in C++ projects is let's see, let's go test CPP. So I might compile something, maybe we'll do C. Like I might do something like void my function void or something. I don't know, it doesn't matter. Printf hello world include stdioh int main void and this is just gonna return 0 for now. So what I do all the time is I say like gcc -o test.c wall wextra pedantic where. Oh, I thought that he warned on unused functions. Oh, maybe it's like, let's just say I do this for now. I don't return it in there. He's going to say like, hey, control reaches end of non-void function, right? And something that I used to do all the time is when I was like really, really hacking shit up, I would do this thing where like our project with like hundreds of files would have these rules, and I would just be like, pragma gcc I'm forgetting the fucking terms. No, this is like so fucking useful. GC pragma wall or like warning disable yeah. I would do something like this. So I'd be like, look, I don't fucking care about this like return type error right now, and then it would like compile. So like something like being able to like fucking like toggle on and off stuff like while developing is so huge, right? Because then you can go, okay, so I know that all of this shit is broken, but like please just let me compile it and run it anyways, because like I'll take the hit. I don't care right now. And then you could do stuff like, you know, you could turn off these warnings for like unused variables while you're developing, and then at the end delete this, and then the compiler goes like, whoa, what is all this shit that you left around that you're not using? So like that pattern is like really sick. So being able to turn it on and off is like incredibly helpful, because when you're developing, you don't want all the checks, but before you commit, you definitely do. At least I shouldn't say you. I definitely do. You as in the royal you who is me or something. Who fucking cares? Okay, what was I doing? What were we fucking working on? We were working on right, we decompressed a Huffman block. Pretty cool. Okay, so we are at 1 hour 40 minutes, and the question is do we think that we can get through something else interesting? We could look at dynamic Huffman blocks. Let's see how fucking crazy these are. Does Zig have a preprocessor? No, as far as I understand, the goal is to just have any Zig that you can write generate more Zig, so you can have like compile time things that are like analogous to C++ templates, but like a little bit more advanced. It's kind of like just like you can run a function and it'll generate more stuff. So you can like generate types with functions, and then you don't need the preprocessor. It's kind of like the argument, which I can see the argument for. I don't know if I've seen some like wacky shit where you could even do stuff like generate a struct with specific field names by kind of like they kind of like expose compiler internals to you a little bit. I think. Let me think about this. I think I saw somewhere Zig generate struct. I think it's possible. There's a way. I'm trying to think. Maybe in like stud building. Oh yeah, it's a building Zig structs compiler. And this is definitely what I clicked on. And they have stuff like you can have a struct here with these fields, but you can also have this other version that's like extra, this other representation of it where you can actually look at the fields by string name and then feed them values, right? So you can do something like, hey, I'm going to like allocate some fields for this guy, and I'm going to give him this name, and this is his type, and this is his default value. And then you can just like bang through it in like a function, which is like arguably this is definitely worse in some ways than like a C macro, right? Like a C macro, all you have to know in order to do your metaprogramming is you just have to know how to type the thing that you want in your source code. Where this is like, now you need to know how to generate the compiler internals so that you can generate a type with this struct field that has this layout and fields and decals. And like, that's like not as easy. Like the entry cost is high, but I think that like the upper bound on complexity is like, it kind of like means that you just have to write code. It's you don't have like some of like the really wacky shit that like everybody has like macro PTSD. I don't think that it's as bad as everybody I've worked with seems to think they're worse than I do. Probably because I haven't hit the cases where it's like hell, but this is like, this dodges the problems that people have with it, right? Like the fact that you could like construct method names through macros is like, don't do that, right? Or like in Python, it's the same shit, right? Don't fucking make a function out of strings and then stick them together. I guess this is technically doing the same thing. So maybe you're not really dodging it, but yeah, I'm not really sure. Most of the time you want to see macros with standard syntax and hygienic substitution, not full-blown AST manipulation. Yeah, I do kind of agree with that. But I can also see like the Zig mantra seems to be along the lines of simple, but like not that kind of simple. like if you can do it with less code in the compiler, then that's better than having to make a preprocessor system. I think that seems to be the vibe I get from them. Here's an issue discussing adding a sloppy flag and Andrew's reasoning for rejecting it. Curious. So I'm assuming that this is equivalent to like disabling warnings. Here's what I think about unused locals and unused parameter errors. Zig's language is designed to prevent bugs by making strategic use of friction. Okay, yeah, I like that. For example, this is why coercing U16 to U32 works without syntax at all, particularly the other way you have to use intcast. Love that. Okay, cool. I'm on board so far. Intcast does not mean that your code is wrong. It documents the code correlates with a higher chance of bugs. And I guess there's also the addition that you have like the runtime checks that will crash. So there's like friction both in terms of writing and in terms of like working with it. Likewise, Zig supports unused parameters, unused locals. However, such things are indeed correlated with a higher chance of there being a bug. So you have to confirm that the non-use is intentional with additional syntax, just like with intcast. Right, so I think that's a fair point as well. Friction by nature is uncomfortable. People seek comfort, meaning that people seek to program in a way that language does not use to induce friction, making use of all variables and parameters, blah, blah, blah. While experimenting corresponds with the principle of Yagni, which is programming style. So he's kind of saying, as you build up your function, you should not be pulling things in that you won't need. Zig language is opinionated. There's one canonical ways to do things. There will be no sloppy mode and no divergence for debug to release. For those who find their own programming style to be in conflict with language, I do have a suggestion, which is tooling. It would be reasonable to make a command line tool that fixes... Okay, so I kind of get what he's saying, right? He's saying that by adding parameters that are unused, you are taking on complexity now that you might not need. I find that I often work outside in instead of inside out. I know that I want to stub out functions that generate concepts, right? Like, so how do I say this? Like if I'm writing like a loop that's like function do some algo, what I sometimes want to do is I want to say like, well, what are the steps of the algorithm? There's like, like separate or like split vectors, right? Say that I have like some arguments, right? Let's like, I have like some U8s and I want to split them up. And I know that I'm going to go from like a bunch of U8s to a bunch of U8s. So this guy's going to have like split args. Like, I'm just like, I don't know, it doesn't really matter, right? But the idea that I know that I want to do this and then I want to do something with like var processed is equal to process args split args or something, right? Like, I kind of know that I want to like build the structure of what I'm doing before I build the implementations. For like the same reason though, right? It's because I don't know. I want to make sure that when I'm writing my functions, I am not overdoing work in some areas that I don't need to do. And like I want to make sure that like it flows nicely. So I do things this way very often, and then with what he's kind of saying is, well, if you stub out your functions first and then mark them as all undefined, who knows if you're actually gonna need them? And I'm like, well, I'm gonna fucking need them. Like, and I don't like the idea of my tooling putting in these warnings, these like warning dodges for me, because like I want that reminder, right? Like when I stub out all my functions, I need to make sure that I actually fucking implement them. And if I like take in a variable and I don't use it, then like that's a bug. Like I agree with that. But I don't want that to happen until I care. But whatever, I can see the argument. That doesn't address eating half the code in the middle. The test shit, it's so annoying. Yeah. I mean, I will say that if there's one thing that's going to make Zig do well, it's the fact that the creator is very opinionated. I think that like this is a well thought out point with like strong like backing values and consistency throughout the language. So even if you don't like it, I'd rather take a consistent, strong dictator than the C++ committee. Like 100 out of 100 times. Okay. We wasted enough time that I don't really want to start on dynamic blocks. So I think I'm going to call it there. I'm pretty happy with that progress. This like zlib decompressor thing went a lot better than I thought it would, which is pretty sick. So happy with that. Where did we get to? So we fixed some bugs with our Huffman table generation that allowed us to pull in this like fixed Huffman table from the RFC. We generated it, we validated that it was right, and then we handcrafted. I shouldn't say handcrafted. We generated a Huffman block without any external code, just our own code, that is a statically encoded compressed block with this Huffman table. So pretty happy with that. And then we managed to decompress. We fed that block into zlib. Zlib decompressed it fine. We fed it into our thing. We decompressed it fine, and we integrated it with the overall zlib decompressor that's going one block at a time right now. So happy with that. Made lots of good progress. What's wrong with the C++ community? Community, I don't really have strong opinions on. Committee, though, what's wrong with committee? I think that, I think C++ made some major mistakes with, again, this is just, my opinion, who fucking cares, man? But, when somebody realized that the template system was Turing complete and started doing shit with it, somebody else should have been like, holy fuck, we have to stop this, and whatever they're doing, we need to integrate it into the language, right? But instead of in C++ 17 they added context per if, right? So you have compile time if statements, and now you can conditionally compile out code based off conditions. But the way to do that before that was fucked. Absolutely fucked. You instantiate two versions of a template, right? And let's see if my C++ metaprogramming is still Turing complete is hard to prevent. Well, yeah, I agree with that. I'm just saying that you should. I'm not saying prevent it. I'm saying give better alternatives. So if you wanted to conditionally compile out something, I think the common pattern is you have template type name t. You have a struct. And this is my condition. Say you want to have two types, right? You want to have some condition that says if this is true, I want it to be type A, and if it's false, I want it to be type B. You do this thing where you say, template I think you say type name A and type name B. Struct my condition true A, B or something. This guy gets a type using type is equal to A. And then you do the same thing for false and set it to B. And then you can like construct something with my construct thing is dependent on some condition. You can then say that like your type is like my condition be int void type X. Like, this is how you would like do some sort of like conditional compilation. And then there's like all sorts of other shit where sometimes you express invalid states by just deleting the type. And then it goes, well, if you try to construct it with these parameters, then it fails. But if you try to construct it with these other parameters, then it succeeds. And so we're going to like conditionally fail and expect the failures as errors, blah, blah, blah. And it's just like, somebody should have just fucking, like, they should have just gone like, okay, fuck it. We'll let you run functions at compile time. Like, don't do this. Don't fucking do this. But instead what they did was they embraced this. And the standard library is built completely off stuff like this. And it's fucked. Like, if you try to go and like write a library, you have to have some like massive fucking balls to try to support like what is ultimately very reasonable behaviors. Like, if you just want to say like, oh, if this thing is a floating point thing, or if it's like an integer thing, I want to do two different math expressions. It's just so fucking hard. You have to make one function that doesn't compile for floats and one function that doesn't compile for ints, and then make sure that they do compile in one case and not the other. It's so fucked. The whole thing's fucked. And so that's why I'm like, you know, when I said I'd take a opinionated Zig guy over the C++ committee, it's like any committee that's choosing this is nuts. They're crazy. I don't agree with them at all. Probably on anything. Like, you know? And I mean, I'm over exaggerating, right? Obviously, the C++ is like a widely used thing, and there are reasons why everything is done, and nobody is out here trying to make something bad, right? And it's just like things evolve, and we learn things over time. We find out that we made mistakes in the past, whatever. But if there's a Zig guy and his mantra is, I want to keep things simple and fuck you, and like, I'm going to do what I think makes sense, it's like, I'll take that every time. It's basically what I was trying to say. To be fair, I'm sure the committee disagrees with most of that shit, but it's what happens when you average out wants of a bunch of different groups of people. Yeah, that wouldn't surprise me. If you have like, you end up with the average of a bunch of opinions in strong opinions in different directions means like a muddle of shit in the middle or something. I could see that. Anyways, C++ rant over. We're getting distracted. You need a dictator. Yeah, I mean, that's what I think. Let's just be clear, not everywhere. Just for just for my programming languages, and it has to be a dictator that I agree with, and that I get to choose to follow. Let's say that. Yeah, okay. So let's see. We talked about what we did today. If you like what you saw, I stream most days at around 2 o'clock Pacific time. So right now it's 4 o'clock Pacific. We stream for like 2 hours. So anytime between 2 hours ago and now. VODs go up to YouTube around like a day later. So there's a YouTube link in the Twitch description, as well as a GitHub link in the Twitch description. If you don't see the links, because some people don't, then it's the same username on both. There's YouTube playlists for a bunch of like previous projects. So we've done like virtual file systems, operating systems, neural networks in Python, some like diff tooling, some like web dev. We do, whatever I feel like working on, which has a trend towards low-level things, re-implementing things that don't need to be re-implemented. That's kind of what's in there. So if you want to check it out, go ahead. If you're on YouTube, there should be a Twitch link in the YouTube description, which if you made it this far, there's like a high chance that you'd be interested in swinging by and saying hi live. Yeah, I think that's it. Thanks, guys. Thanks for watching, and I'll catch you on the next one. Bye!